Most security systems are installed without a single page of documentation. No wiring diagram, no cable schedule, nothing. Today, most security installations happen fast, hardware gets mounted, cables get pulled, and the documentation gets skipped. That works right up until something breaks, or a new zone needs adding, or the original installer has left. And then suddenly nobody, not the technician, not the facility manager, nobody knows where that cable runs, what gauge it is, or which panel it terminates at. A good wiring diagram fixes this. It shows where every device sits, how every cable runs, and exactly what gauge and type of cable to order. In this video, I will show you how to create a complete electrical and security wiring diagram in EdrawMax, step by step, starting with what a proper diagram actually needs to include. By the end of this video, you will have built a wiring diagram that any installer could pick up and work from, without calling you to ask a single question. A security wiring diagram is a scaled floor plan that shows where every security device is installed, how those devices are wired together, and what cable carries each connection. It is used by security engineers to design the system, by electricians to pull the cables, by technicians to troubleshoot faults, and by facility managers to document the installation. A proper diagram combines a building floor plan with 4 overlaid security systems: intrusion detection, access control, CCTV, and power distribution, each one shown cleanly on top of the spatial layout. Before we start drawing, let's quickly go through the 4 systems you will see in almost every commercial security installation. First, the intrusion detection system, or IDS. This covers motion sensors, door contacts, glass break detectors, and the alarm control panel. Its job is detecting unauthorized entry. Second, access control, or ACS. Card readers, biometric scanners, magnetic locks, and the controller that decides who gets in where. Third, CCTV. IP cameras, a network video recorder, a PoE switch, and a monitor at the operator station. Its job is visual surveillance and recording. Fourth, electrical power. The AC distribution panel, power supply unit, and battery backup. This system does not detect anything. It keeps the other 3 running, even during a power outage. Each of these 4 systems has its own cable type, its own topology, and its own color on the diagram. That's why professionals draw them on separate layers: red for IDS, blue for ACS, green for CCTV, purple for power. Before we open EdrawMax, 3 rules. These are what separate a diagram that engineers trust from one they bin. If you remember nothing else from this video, remember these 3. Rule 1. Cables follow walls. No diagonal lines across open room space. Every cable runs along a wall or a ceiling, turns at 90 degrees, and reaches the device from the nearest wall surface. Rule 2. Each system gets its own cable route. An alarm cable and a CCTV cable don't share a conduit. On the diagram, their lines run parallel to each other with a small offset, showing separate conduits on the same wall. Rule 3. Every cable gets a label. Not just which device it connects to, but what type of cable it is. 22 AWG 4-core alarm, Cat6 UTP PoE 2.5 mm AC supply. The installer needs to know what to order and what to pull. These 3 rules are what make a wiring diagram useful on an actual job. Not just as a reference document, but as a tool someone can work from on site. EdrawMax handles all 3 of those rules automatically. That's the reason we are using it, and I'll show you exactly why in the next 30 seconds. The orthogonal connector mode forces every cable line you draw to route at right angles automatically. No diagonals, even if you try. The built-in security and access plans library has every security symbol you need: motion sensors, card readers, cameras, alarm panels, NVRs, already drawn, ready to drag onto the canvas. And the layer system lets you put each security system on its own layer. Work on one at a time without the others getting in the way. That's something no hand-drawn diagram or basic tool can do. Okay, let's start building. I already have the office floor plan saved as a symbol in my EdrawMax library. I'll drag it straight onto the canvas. This is a small commercial office layout. Reception, common office, server room, conference room, manager's office, and a fire escape corridor at the bottom. Before placing any device, set 3 things. Orthogonal connectors. Click Connector. Set line style to orthogonal. Grid and snap to grid, both on, from the View tab. 4 layers, 1 per system. Power, IDIS alarm, access control, CCTV. 3 settings, 90 seconds. That's all the setup you need. Skip any one of them, and you'll spend the rest of the session fighting the software. The first system to draw is always power, because every other system feeds from it. DIS T01 goes in the top right corner of the building. That's where mains power enters from the street grid. In the server room, I place the main panel. One box that contains PSU01 and BAT01 for power supply and battery backup, NVM01 and the PoE switch for CCTV, and AP01 and AC01, the alarm panel and access controller. Centralizing everything in the server room is standard practice. It's the most secure room in the building. Then I draw the power cable. Thick solid purple line from DIST01 across the top wall, labeled 2.5 nm AC supply. That run is the electrical backbone of the entire system. Intrusion detection. Switching to the IDS alarm layer, we have 9 devices to place. Rule before we start: place everything first, wire after. You can't plan a clean cable route until you can see all your endpoints at once. Motion detectors first. MD01 in reception, MD02 in the server room, MD03 in the manager's office. 3 sensors covering 3 distinct zones. Motion detectors always go in corners. A corner gives you the full diagonal of the room from a single sensor. Door contacts next. DC01 on the main entrance, DC02 on the conference room door, DC03 on the rear exit. These go on the door frame, not on the door arc itself. HS01, the horn strobe, sits outside the building boundary, above the main entrance. Exterior mount. Then the specials, GBD01 on the reception window facing the street, because that's the most vulnerable point to forced entry. SD01 smoke detector in the server room. Mandatory in any room with powered equipment. Now we wire the IDS system. The topology is called daisy chain, and it's the standard for alarm systems. 1 cable leaves the alarm panel. It travels around the wall perimeter. Each sensor taps off the cable as it passes, like beads on a string. Across the top wall, HS01 taps off above the entrance, and MD01 taps off at reception. Then come the interior branches. Short runs off the perimeter loop to the devices inside the building. GBD01 on the reception left wall. MD02 and SD01 in the server room. Along the corridor bottom, DC01 and DC03 tap off at the entry and exit points, and DC02 at the conference room door. Down the right wall, MD03 taps off at the manager's office. Each tap-off gets a junction dot. Then the loop returns to the panel, closing the circuit. Finally, label the bottom run as 22AWG 4-core alarm cable. Access control. Switching to the ACS layer. CR01 goes at the internal door in the common office area. This door controls access between the upper zone and the lower zone of the building. The card reader always faces away from the restricted area. MAG01, the magnetic lock, goes on the door frame itself. At the server room door, the highest security zone, I place CR02 and Bio01 side by side. A card reader and a biometric fingerprint reader on the same door. Two devices at one entrance means two-factor access. ES01, the electric strike, goes on the server room door frame. Then the cables. Access control uses two line types on the same layer. Blue dashed is signal, the reader cable. Blue solid is power, to the lock. All ACS cables radiate from AC01 inside the server room. The cable to CR01 and MAG01 runs along the corridor bottom wall, then up the right side through the manager's office wall to reach the internal door. That vertical run on the right side is where the label goes, 6C18WG reader cable. The server room door devices, CR02, BIO01, ES01, are a short run. The controller is right there. CCTV. Switching to the CCTV layer. 3 cameras. TM02 in the conference room, covering the access point into that zone. KM01 sits in reception. KM03 in the common office, covering the right side of the upper zone. 3 cameras, reception, conference room, common office, each rotated so the cone shows exactly what it watches. CCTV uses star topology, the opposite of daisy chain. Every camera gets its own dedicated Cat6 cable running all the way back to the PoE switch. No sharing. The Cat6 trunk exits the PoE switch, runs along the ceiling just inside the top wall of the common office, and drops down to each camera. I label the trunk Cat6 UTP PoE. The wiring is done. Now the final touches, a title heading at the top and a quick pass over the cable lines to make sure every system reads cleanly. First, the cable lines. I check that each system's line style is consistent. Green dashed for CCTV. Purple solid for power. Blue dashed and solid for ACS. Red dashed for IDS. And I confirm every cable run has its type label sitting on a clear stretch where it's easy to read. 22AWG, 4-core alarm cable along the bottom, Cat6 UTP PoE on the CCTV trunk, 6CTAWG reader cable on the right vertical, 2.5mm AC supply across the top, 4 labels, 4 colors, 4 systems. Done. Then, the final pass on the title at the top of the diagram. I add a heading bar at the top of the diagram. Bold white text on a dark blue background reading, Electrical Security Wiring Diagram. This is the first thing anyone opening the file sees, and it tells them exactly what they're looking at without needing a single click. Last step, saving the diagram and getting it out to the people who need it. File, export, PDF. I export at 300 dpi, so it prints cleanly when an installer needs a hard copy on site. The PDF preserves every cable color and line style exactly as I drew them. What's on screen is what shows up in print. And if I need to send it to someone who doesn't have EdrawMax, I generate a share link from the same menu. They open it in any browser, no install needed. Print copy for the site, share link for the team. That's the diagram complete. Before we wrap up, 4 mistakes that show up on almost every beginner security wiring diagram. 1. Cables that cross open room space. 2. Devices placed without a floor plan base underneath them. 3. Unlabeled cable runs. 4. No clear title at the top. Without a title bar, even a perfectly wired diagram looks unfinished. A bold heading tells anyone opening the file exactly what they're looking at before they read a single device tag. Fix these 4 and your diagram instantly looks like it came from an engineering firm. The sequence that makes it work. Canvas setup first, so the software works with you. Power before security, so every system has a source. devices before cables, so the routing makes sense. IDS as a perimeter loop, ACS as radial runs, CCTV as a star trunk. Title, final pass, export. That order is not arbitrary. Each step depends on what came before it. That's a complete electrical and security wiring diagram. 4 systems, 1 floor plan, built in EdrawMax from scratch. If you decide to make your own, click the link in the description. Hit like, subscribe us if you find it helpful, and drop a comment about anything you would like to learn about. See you until next time.